Hey everyone, my name is Cherry. I am here to demonstrate Kirchoff's first law, which states that the current that is going into the junction must equal to the current that is going out into the junction. Now in here I have a circuit board that I already had made the wire connections, and on the right side I have a multimeter that can measure current, voltage, and a resistance. Now in the circuit board, we have two batteries that has a total voltage of 3 volts. I also have 3 resistors over here, and all of those 3 resistors have the same resistance, which is 330 ohms. Now the current will be flowing in here, going here past the first resistor, and in here, since there's 2 resistors, the current will be split over here. Now we're gonna measure the first the current that is going into the junction. Now in order for me to do that, we have to cut one of these wires and put our ammeter to measure the current. Now you will see it in here. And that is 6.1 milliamps. I have to connect it again. Now we're gonna measure the current that is going in here, and then we'll cut the wire over here and put our ammeter. That is 3.0 milliamps. Oops. Now the last one we'll measure is the current that is flowing in here. Now again, we have to cut the wire in here, and then we'll measure. That is 3.0 milliamps. Now, as you remember, the current that is going into the junction is 6.0 milliamps, and then the current that is flowing over here is 3.0 milliamps, and then the current that is going in here is 3.0 milliamps. If you add this to current over here, the total will be 6.0 milliamps, which is equal to the current that is going into the junction, and that is what we call Kirchoff's first law.
We studied Kirchoff's law for our project, which states that the sum of currents flowing into a node equals the sum of the currents flowing out of a node. The mathematical representation for this is the sum of I underscore I is equal to the sum of I underscore O. This can be rewritten as the sum of I underscore I minus the sum of I underscore O is equal to 0, where I underscore I represents the inflow currents and I underscore O represents the outflow currents. So for the calculations, we had a inflow current into the junction of 6.1 milliamps, and we had 2 currents flowing out from the junction of 3.1 milliamps and 3.0 milliamps. So we add these 2 outflow currents and then subtract it from the inflow current to get 0. Since the expected value was 0, percent error is not applicable in this situation. However, the results are in line with expectations.